Hey guys, welcome to my new video. This is on paper 2 of the Edexcel GCSE Maths exams of 2017. This paper was sat on the 8th of June. It's a 1 hour 30-minute exam, and I'm going to go through 10 questions out of this exam. I'm going through questions 2, 4, 6, 7, 11, 16, 18, 19, 21 and 22. As with all the exams they put the harder questions at the end, so I'll be answering mostly questions from the end of the exam. So let's get straight into it. Starting with question 2. This question says, on Saturday, some adults and some children were in a theatre. The ratio of number of adults to the number of children was 5:2. Each person had a seat in the circle or had a seat in the stalls. 3/4 of the children had seats in the stalls. 117 children had seats in the circle. There are exactly 2,600 seats in the theatre. On Saturday, where the people are more than 60% of the seats, you must show you're working. Okay, so the first thing I would notice is that it's giving you the amount of children in these two figures. You need to use your knowledge of basic fractions to figure out how many children in total there are. So you know that 1/4 of the children equals 117. That's what that's telling you. Then 3/4, well, you need to multiply that number by 3. 3/4 will be 351, and then therefore the total number will be 468. Now, then you need to use your knowledge of ratios, and this ratio is telling you that the number of adults to children is 5:2, so 2 parts equals 468. Divide that by 2 will give you what 1 part is worth, so 234. And then we need to multiply that by 5 to find out the number of adults that there are. So here's the number of children, 468, and we multiply that by 5 to get the number of adults, which will come to 1,170. Now we know how many people in total there are in the theatre. Add those two together and we'll get 1,638 people in total. Then, we still haven't quite answered the question because it's asking for a percentage. Is this more than 60% of the seats? And then you need to use your knowledge of percentages and divide that number. We need to know how to convert that into a percentage, which you know is divided by the total times 100, and this ends up equaling 63%. So yes, answer the question is yes, there are more than 60% of people in the seats. For question 4, this is another wordy question. It says, Ollie drove 56 kilometres from Liverpool to Manchester. He then drove 61 kilometres from Manchester to Sheffield. Ollie's average speed from Liverpool to Manchester was 70 kilometres per hour. Ollie took 75 minutes to drive from Manchester to Sheffield. The question says, work out Ollie's average speed for his total drive from Liverpool to Sheffield. So for one part of the trip we're given the speed, and then for one part of the trip we're given the time. And I'd say the most useful formula for this question would be this one that says speed equals distance over time. And one way to approach this, there's a few ways you could do this. You could do this with ratios perhaps, but I'd say the easiest way or the quickest way would be to work out the time it took to travel this first 56 kilometers, and then work out the total time, the total distance, and then get the total average speed. So we need the time. So if we rearrange this formula, we'll get time is distance over speed. So the time for the first part of the trip will be the distance, 56, over the speed, which was 70, and put that into your calculator, you get 0.8, and 0.8 of an hour is 48 minutes. So now we can work out the total time that it took by adding on this 75 minutes and then we'll get the total time, which was total time was 123 minutes. Then we know the total distance as well. If we add the two distances together, we get 117 kilometers. And therefore we can use this original formula again to work out the total average speed for the whole trip. Now be careful with these units because the answer will need to be in kilometers per hour. So if we do this sum here, 117 over 123, that's going to give us kilometers per minute. Now you could change this to hours by dividing it by 60, and if you divide that by 60, you get 2.05 hours. And then if you divide 117 by 2.05, you get 57, and you get some decimal places. If you round it to one decimal place, you get 57.1 kilometers per hour. And you could leave it like that. You could round it to 57, and the examiners were accepting anything from 57 to 57.1. So that answer there is fine. The second part of this question says, Janie drove from Barnsley to York. Janie's average speed from Barnsley to Leeds was 80 kilometers per hour. Her average speed from Leeds to York was 60 kilometers per hour. Janie says that the average speed from Barnsley to York can be found by working out the mean of 80 kilometers per hour and 60 kilometers per hour. If Janie is correct, what does this tell you about the two parts of Janie's journey? Now, there's only two conditions in which this can occur. It's if both of the distances were exactly the same, or if you look at these speeds carefully, 60 kilometers per hour is 3/4 of 80 kilometers per hour. So it can occur if both distances were equal, or if the distance from Leeds to York is 3/4 of the distance from Barnsley to Leeds. And you can phrase that however you like. But basically you need to identify that that can only occur if there are certain conditions under which he's traveling. If any other if there's any other situation occurring, like say if this distance is double the other one, then her statement will be incorrect. Question 6 says, Anya wants to invest £25,000 for 3 years in a bank. It gives you these details for personal bank and secure bank, and then it asks which bank will give Anya the most interest at the end of 3 years. You must show all you're working. And personal bank has 2% for each year using compound interest, and secure bank is again using compound interest at 4.3% for the first year and 0.9% for each extra year. So hopefully you're familiar with the compound interest formula, which says the amount you end up with is equal to the principal, or the starting amount, multiplied by 1 plus the rate, or the interest rate, divided by the number of times it compounds per year, to the power of that same number n times the number of years. And we can use this formula, or we can do it without the formula. It's up to you. I'm going to use this formula because I believe it's good practice, but also you could simply multiply this amount by 1.023 times and you get the same answer. So for personal bank, let's use our compound interest formula to work out what we'd end up with after 3 years. and basically we just need to make sure we plug in the correct numbers and get the correct answer out. So our amount after 3 years will be the principal, which we start with, which is 25,000, multiplied by 1 plus the rate, and we have to change that to a decimal, so this rate here is going to be 0.022% as a decimal, over the number of times it compounds per year. So it tells us that it's 2% for each year, so it's compounding once per year, and then we get again that 1 times the number of years, which is 3. So we could simplify this a little bit, just so we're not having to put all of that into our calculators. This is obviously just going to be 0.02, so this is going to be 1.02 to the power of 3. And then if you put that into a calculator, you will get 26,530.2 pounds. So that's the amount we'd end up with using personal bank. Now, it's always interesting to have a guess which one you'd think will end up with the most at the end. Due to this 4.3% for the first year, I'd say that secure bank will end up with the most, but obviously that's just a guesstimate, and you have to obviously do the full working out to make sure. So the rate here, the rates actually are 0.043 for the first year, and then it changes to 0.009 for the next 2 years. Now we're going to have to do 2 calculations here because the rate changes. So for the first year, we'll end up with 25,000 times 1 plus 0.043 over 1 times to the power of, oops, not 3, that will be to the power of 1, because that's for 1 year. And if you put that into your calculator, you end up with an answer of 26,075. Then you have to use that as the principal for the next part of the calculation. So make sure you're putting this number into the new calculation. Oops. Which is 26,075 times 1 plus 0.009 over 1 to the power of 2 this time. And if you work that out, you get 26,546.46 pounds. And then you just need to simply compare those two numbers, which is more, and then you can write your statement, your answer in a statement, and you should choose secure bank. Always make sure to finish your answers in these exams by answering the question. I'd say if you did all of that working out, you'd probably still get 4 marks, but just in case, always make sure you answer the actual question at the end. Question 7 says, a number n is rounded to 2 decimal places. The result is 4.76. Using inequalities, write down the error interval for n. Now I think this is new terminology in the new GCSEs. I think these used to be called lower and upper bounds. Don't quote me on that, but I think this is a small change. So if you've done lower and upper bounds, it's the same thing, but now we need to use inequalities to write the answer. So we started with a 3 decimal number, and obviously it started with 4.7 something, and it was 3 decimal places, and we've rounded it to 2 decimal places. So what could these two numbers be? What's the lowest it could be and what's the highest it can be? That's what this question is asking. So if you think of a number line and 4.760 is right in the middle, what could these two upper and lower numbers be that would round to this number. And the lowest number will be 4.755, because that anything bigger than that will round up to 4.760, and anything lower will round down. And if you think of the numbers bigger than 4.760, everything less than 4.765 will round down, but anything larger than that will round up. So our error interval starts at 4.755, and my inequalities here will be greater than or equal to, because the number could have equaled 4.755 and it was still round to 4.760. And here I'm going to use just a less than symbol, because it can't equal 4.765, but it can be anything less than that. So my error interval looks just like this, and that's all you need to do to answer this question, finding the lower and upper bounds for this error interval. On to question 11. Question 11 says, solve these algebraic fractions to find a solution for x. Now, I think the quickest way to answer this is to find a common denominator between these denominators and then cancel them out as you go. So hopefully you can see the common denominator of 4, 3, and 6 is 12. And then what you can do is simply multiply each fraction by what you need to make the denominator 12. So for this first one, I need to multiply 4 by 3, so I need to multiply the top line by 3 as well, and then that bottom line becomes 12. Here I need to multiply the denominator by 4, and that makes the denominator 12. And then on this side I need to multiply that fraction by 2 to make the denominator 12. And here I can cancel out the denominators. If you're unclear as to why I can simply cancel these out, maybe watch my video on algebraic fractions and have a bit of practice on those, and you'll understand why I can simply cross those out. But I'm going to move on now. So once I've cancelled those out, I can expand those brackets, so I'm left with 9x minus 6 minus 8x minus 20 equals 2 minus 2x. And then I need to get all of the x's on the left hand side and all of the numbers on the right hand side, and I can solve for x. So I'll start by simplifying this side. So I've got 9x take 8x will be x, and minus 6 minus 20 will be minus 26. And on this side I've still got 2 minus 2x. Then if I bring that minus 2x over to this side, that will be plus 3x. And if I bring this minus 26 over to this side, that will be plus 28. And then I end up with, I just need to divide this side by 3, I end up with x equals 28 divided by 3. And you can leave it like that, or you can write 9 and a third. Either answer will be fine there. Yeah, I think there's a few ways you could tackle that. The longest way I would say was to multiply everything by every number here to cancel them all out, but I would say the most efficient method is to find the common denominator. Question 16 says, using algebra, prove that 0.136 and the 3 and the 6 are recurring times 0.2 recurring is equal to the value 1 over 33. So don't be fooled, even though this is a calculator exam, it says use algebra, so we can't just put that into a calculator, press the SD button and say done. We need to show what this is as a fraction and what this is as a fraction algebraically, and then multiply them together to get 1 over 33, which I think there's quite a few marks in this question. I can't remember off the top of my head how many marks it was worth, but there's quite a bit of work to do here. So the algebraic method to change these recurring decimals into fractions goes something like this. Hopefully you've been practicing something similar. There's a few different ways to change recurring decimals into fractions, but this is the method I like to use. So we say that x equals 0.2 recurring. Then we multiply, so we've come up with an equation and we multiply both sides by 10 and we get 10x equals 2.2 recurring. Then what I can do is actually subtract this first equation from the second one. So I say 10x minus x equals 2.2 recurring minus 0.2 recurring. And what this does is this cancels out the recurring part of the decimal, which is the part we need to get rid of to write this as a fraction. And over this side it becomes 9x, and here I'm just left with 2. And then I divide by 9 and x equals 2 over 9. So that's the algebraic method for changing recurring decimals into fractions. Then we need to do it for 0.136 recurring. And this is a bit more involved because we need to take a few more steps in order to get rid of the recurring part of this decimal. I am going to skip multiplying it by 100, but I multiply it by 10 first, and I get 10x equals 1.36 recurring. And then I need to multiply it not by 10 again, but by 100. So I get 1000x equals 136.36 recurring. What this does is this makes sure that these recurring parts of the decimals match up. So when I subtract them, that I can cancel these out. So my next line will be 1000x minus 10x equals 136.36 minus 1.36 recurring. So you can see there that I've used these two equations to get rid of these recurring parts of the decimals. And so I get 1000 take 10, 990x, minus 136 minus 1, 135. And so x equals 135 over 990. And I believe you could simplify. You could use your calculator to simplify that. You don't need to show how to simplify that the long way, and you would get 135 over 990 equals 3 over 22. Okay, so that's the hard part of this question over and done with. The rest is a bit easier, really. So all we need to do now is, because this was 0.2 recurring, 2 over 9, and this was 0.136 recurring, which was 3 over 22, and it's asking us to multiply these two fractions to show that they are 1 over 33. So all I need to do now is 2 over 9 times 3 over 22, and simplify some of that. So this will become 1, this can become 11, this can become 1, this can become 3. And you can see that 1 times 1 is 1, and 3 times 11 is 33. So we've used algebra to prove that those two recurring decimals multiplied together equals 1 over 33. Okay, question 18. Question 18 made me a little bit frustrated, because I know that it's the type of question, if you know the trick, it's easy. If you don't know the trick, you probably won't get this question. So it's asking us, it's given us an equation, 16 to the power of 1 over 5 multiplied by 2 to the power of x equals 8 to the power of 3 over 4. And it asks us to work out the exact value of x. So we need to use our knowledge of index laws to find what x equals here. And the only way we can do this really is to make sure that all of these numbers have a base of 2. So we need to realize that 16 is 2 to the power of 4, right? So 2 times 2 times 2 times 2 will be 16. And 8 is 2 to the power of 3. So we can rewrite this equation as 2 to the power of 4 times 1 over 5, to the power of 1 over 5 times 2 to the x equals 2 to the power of 3 to the power of 3 quarters. And we can simplify these a little bit, so that will be 2 to the power of 4 over 5 times 2 to the x equals 2 to the 9 on 4. Now, what we need to do is use the index law that says these two powers added will equal this power. If you're not familiar with the index laws, perhaps see my video on, it's called the 3 index laws you need to know. It goes through this idea, but we know that 4 over 5 plus x needs to equal 9 on 4. And then we can solve this for x, so we could say x equals 9 over 4 subtract 4 over 5. So, excuse me. 9 over 4 times 4 over 5. And well, cross multiply here perhaps. And this will be 45 over 20 minus 16 over 20, which gives us 29 on 20. And you could leave it like that, or you could change it to a decimal, 1.45. So x equals 1.45 there. Again, I think if you realize that the trick at the start of the question, this is quite simple. Okay, question 19 says 2 minus x plus 2 over x minus 3 subtract x minus 6 over x plus 3 can be written as a single fraction in the form ax plus b over x squared minus 9, where a and b are integers. Work out the value of a and the value of b. Basically, they're telling us that this can simplify to this in this form, and we need to take all of this here, simplify it until it looks like this, then we can read off the values for a and b. So let's start with this left-hand side. 2 minus x plus 2x minus 3 and all of that. I like to rewrite some questions where there's going to be a lot of working out. It's good practice to rewrite the problem, and it gets you in the frame of mind to tackle that problem. So to start with, to simplify this, we need to get all of it over one common denominator. So basically we need to multiply all of these numerators by x plus 3 and x minus 3. Okay, so let's start. So 2, now 2 I need to multiply by x minus 3 and x plus 3. And I'll warn you now, this is going to be quite long-winded and time-consuming. This is the type of question that makes me groan, because it's just so time-consuming and really, I think, a bit unnecessary, but anyway. So we've multiplied this here by x plus 3, so we've got the same denominators. and then multiply this one by x minus 3. And you can see already that we've got that denominator of x squared minus 9 because this simplifies to x squared minus 9. So this will equal 2. Now if we expand those double brackets, you'll get x squared minus 9 minus, we need to expand these, x. Now be careful with these negatives because that is essentially subtracting everything in this numerator. So I would put a bracket around this for now. So that's going to be x squared, first add as in as last, use 4 to expand these double brackets. So that would be 5x and then plus 6. And again, that's subtracting everything here, so put another bracket around these. So it'll be x squared minus 9x plus 18. And that's all over x squared minus 9. I'm going to run out of room here. Now we need to simplify all of that. So first thing we need to do is expand these brackets out, so we're making sure we're using this negative symbol correctly. So this is going to be, expand these brackets out as well, 2x squared minus 18 minus x squared minus 5x minus 6 minus x squared plus 9x minus 18 all over x squared minus 9. And now we can do a whole bunch of cancelling. So this 2x squared here and this negative x squared and this negative x squared, they all cancel out. 2 minus 1 cancels out. Then we've got this minus 5x plus 9x. Minus 5 plus 9, that will be 4x, and then a minus 18 minus 6 minus 18 will be minus 42 over x squared minus 9. Now let's go back to the question. We need it in the form ax plus b over x squared minus 9. This looks like ax plus b, well actually it's minus b, but that's fine, over x squared minus 9. So we can say a equals 4, b equals minus 42. Okay, 2 more to go. I like getting into these final questions. They get really challenging and interesting. So question 21 says, the diagram shows 3 identical circles inside a rectangle. Each circle touches the other 2 circles on the side of the rectangle as shown in the diagram. The radius of each circle is 24 millimeters. Work out the area of the rectangle. Give your answer correct to 3 significant figures. Okay, so we're given 3 circles inside a rectangle and we're told the radius of the circle is 24 millimeters. And we are told they are identical circles, so they all have a radius of 24 millimeters. So to work out the area, we need the length and width of this rectangle. Well, first thing you can identify is that we can work out the width. It's just 4 lots of that radius of the circle. So we can just say that's 4 times 24, which is 96 millimeters. Then we need to work out the length or the height. And that's a bit more tricky because we can't just simply say, oh, these are all in line, that's 96 as well. We need to use a little bit of mathematical reasoning. So once you've realized we can't directly work out the length, you need to start thinking about how we can find that length. Well, we know that part of it is 24. We know there's 24 down here, but we don't know this distance in here from this center of this circle down to, well, basically here. We need to find that length. But what we are given is this triangle in here. So there is actually an equilateral triangle joining these three centers. It must be equilateral because the centers are in line, the circles are perfectly touching, and these lengths are all the same. So it must be an equilateral triangle. And what we know about an equilateral triangle is that it is made up of two right angle triangles. And that helps us because using Pythagoras' theorem, we can find this length inside this triangle. And we know enough information to find what that height is. So here we know that that's 24. We know that this is two lots of 24, so this length is 48. And then all we're left with is this unknown length, which we can figure out. So I'm going to redraw this triangle over here. So we've got a nice right angle triangle. And this is 24, this is 48, and this is the unknown h. And using Pythagoras' theorem, we know these two sides squared equal this side squared. So 24 squared plus h squared equals 48 squared. And with a bit of rearranging and using our calculator, we come to an answer of 41 point, and you get a whole lot of decimal places. And remember, never round to until you get to the end of questions like this. Always leave your answers with 5 or 6 decimal places, so you're making sure that your final answer is as accurate as possible. So we're going to leave that as 41.569219. Then to work out the height of this rectangle, we can add these two lots of 24. So, or let's just call it the length for simplicity, so we don't get confused. This is going to be 24 plus 24 plus 41.569219. And for the length, we get an answer of 89 and another lot of decimals, 56929. Remember, always go back to the question, make sure you're answering the question. So we've got the width and the length of this rectangle, and we need to work out the area. So the area is going to be those two numbers multiplied. So 96 times 89.5692, and you get if you multiply those two together, you get 8,598.645. And it says round to 3 significant figures, so if we round to this 9 here, that will actually round up to 10. So to 3 significant figures, this is going to be 8,600 millimeters squared. To 3 significant figures. Okay, that's question 21, and the last one that I am going to cover is question 22, which is a sequences question. And these, I think, shouldn't, if you learn this method, I'm just going to go through the method. I'm not going to go through the reasoning behind the method, but if you learn the method and you memorize the method, you'll be perfectly fine, because the only types of sequences you need to figure out in GCSEs is quadratic sequences. You don't need to do cubics or degree 4 equations. So anyway, this question says, here are the first 5 terms of sequence, 4, 11, 22, 37, 56. Find an expression in terms of n for the nth term of this sequence. Again, I'll basically go through the process, which is easy to learn, and also the understanding behind it is quite easy to learn as well. So if you want to understand why this works, you'll be fine. If you want to just memorize the process, you'll be fine as well. But when you're given a sequence like this, you need to look at the differences between the numbers. That should be your first step. So let's just start by finding the first difference. So in this one, we're going up by 7, then 11, then 15, and then 19. And this doesn't look like it's very helpful because it's not a set difference. So we go to the second difference, and this is going up by 4, this is going up by 4, and this is going up by 4. And when you're finding at the nth term for a sequence, when you've got the second difference and they're all the same, you can divide that by 2, and that will be your coefficient for n squared. So because you've gone to the second difference and all of those numbers are the same, you know this is going to be a quadratic sequence. Whatever number you get here, you divide by 2, and that's your coefficient before n squared. The next step is to write out the sequence for 2n squared and compare it to your original sequence. So if you take starting at 1, if you take the natural numbers and you plug it into 2n squared, remember the square numbers, by the way, the square numbers go like this: 1, 4, 9, 16, 25. What happened there? Don't know. 25, and you can go on and on. But if you're multiplying each of those by 2, you get 2, 8, 18, 32, and 50. Now let's compare those to the original sequence. So this is our original sequence: 4, 11, 22, 37, and 56. So how can we get from this 2n squared to the sequence we're trying to find a rule for, or the nth term for? Well, let's look at the first one. 2 to 4, I need to add 2. 8 to 11, I need to add 3. 18 to 22, I need to add 4. 32 to 37, I need to add 5. And then, what do you think comes next? 6. These look very familiar. 2, 3, 4, 5, 6. These are the natural numbers, but we're not starting at 1. So we could say it's n. N just represents the natural numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, forever. But we're starting at 2, so we need to add 1. So we've got this sequence, 2n squared, and we've added on n plus 1 to get to our original sequence. So our rule for this sequence, our nth term, will be 2n squared plus n plus 1. And if you check that, if you put the natural numbers into this nth term, you should end up with the original sequence. So put 1 into here, you get 4. Put 2 into this, you get 11. Put 3 into this, you get 22. Put 4 into this, you get 37. Put 5 into this, you get 56. So that's our nth term for this sequence. And that is all I'm going to cover in this video. Thank you very much for watching. I've put up a video for the first paper for the GCSEs as well, and I got a lot of likes and a lot of comments on that, a lot of positive comments, and that was really encouraging for me. I really enjoyed hearing from people watching the video. Someone said that they watched it and it really helps them in one of their tests. So yeah, thank you so much to all the new subscribers. I think got about 40 or so now, so that's really amazing, and I'm really enjoying making these videos. I should be making videos more often from now on. I had a bit of a break because I was really busy with work, but I have a bit more time on my hands now, so I should be putting up videos a bit more often than I was. But yeah, if you enjoyed this, please leave a comment. If you want to see what videos that I'm making in the future, subscribe to the channel. And if there's anything else that you want me to cover, if there's any topics that you want me to go over, yeah, as I said, leave a comment or send me a message. It's been really nice to hear from people watching the videos. So thank you very much for watching, and I'll see you in the next one. Bye.